Hello everyone, this is Sarath working in VTN project in OpenDaylight. In this video, the flexible path control feature of VTN project in OpenDaylight will be demonstrated. VTN stands for Virtual Tenant Network. VTN is one of the network virtualization models implemented in OpenDaylight. VTN project has two major modules. The first one is VTN Manager. It implements the VTN functionality in the OpenDaylight controller. The second one is VTN Coordinator. It's a multi-controller orchestration application which is part of the orchestration layer in the SDN architecture. Two features of VTN are demonstrated in this video. The first one is the seamless integration between OpenStack and OpenDaylight controller. The second one is the flexible path control mechanism in OpenFlow networks provided to OpenStack data center environments via OpenDaylight SDN controller. The software and tools used in this demo are VTN project source in OpenDaylight, OpenStack iSource version, OVSDB plugin in OpenDaylight, web application for VTN coordinator to display the configuration information and data flows in the OpenFlow network. The application uses the APIs provided by VTN coordinator. Performance monitor application for displaying network statistics in OpenFlow network. This application uses the APIs provided by VTN coordinator and the statistics manager. The network topology used in this demo is two VMs hosted using OpenStack. First one is the video server and second is other server. 3 OpenFlow switches simulated using Mininet. 2 client machines connected to servers via OpenFlow network. Client 1 streaming video from the video server. Client 2 connected to other server. The first demonstration is the seamless integration between OpenDaylight controller and OpenStack using VTN. The VTN manager receives interface creation events from OpenStack via the OVSDB plugin. Using the network, tenant and port information provided by OpenStack, the VTN manager automatically creates a virtual tenant network in OpenDaylight controller. In OpenStack GUI, in Network Topology tab, create a new network and name it public. Public network will use the 172.16.0.0/16 subnet. Configure the IP address pool for the hosts in this network in the range from 172.16.22.210 to 172.16.22.220. On successful creation of public network, launch a new host and name it video server. And add it to the public network. Launch a second host and name it other server. And add it to the public network. The network information that is created in OpenStack is automatically learnt in OpenDaylight controller by VTN manager via the OVSDB plugin events. Using the web app of the VTN coordinator, we can view the configuration of the created virtual network. The network created in OpenStack is mapped to vBridge in VTN, tenant is mapped to VTN, and port is mapped to virtual interface. The UID of the network provided by OpenStack is mapped to vBridge identifier, while the name public of the network is mapped to the description of the vBridge. This VTN is used to show the second demonstration. The second demonstration is the path policy feature supported in VTN. Using this feature, the user can control the paths taken by traffic data flows in the OpenFlow network. Path policy feature implements cost-based packet routing. A path policy is a set of user-defined cost of using the link for transmission. It can specify the cost of using specific switch link. If a path policy is applied for packet routing, the VTN manager chooses the packet route which minimizes the total cost of switch links. Flow condition is used to determine path policy to be applied for packet routing. VTN manager provides three APIs for enabling the path policy feature. First one is the flow condition API, second one is the path policy API, and the third one is the path map API. For this demonstration, a video will be streamed to client 1 via the OpenFlow network from the video server. The path taken by the video traffic is video server, switch 1, switch 3, client 1. Additional traffic is added to this path by sending traffic from other server to client 2 to make it congested. This makes the video quality streamed to client 1 deteriorate. Now, using the path policy feature, we can redirect traffic to an alternate path, switch 1, switch 2, switch 3. This improves the quality of the video streamed to client 1. On the top left is the client 1 console showing video streamed from the video server. On the bottom left is the performance monitor application showing real-time traffic data chart of the OpenFlow network. On the right side, the web application displays the path taken by data flows in the OpenFlow network. A fireworks video is used for this demonstration. This video is streamed from the video server to client 1 as seen in the client 1 console. Using the web app, video traffic flows between video server and client 1 can be displayed. The video traffic flows from the video server take the default path, that is video server switch 1 switch 3 client 1 as displayed in the web app. Additional data traffic is sent from other server to client 2. The additional data traffic takes the default path. This additional data traffic congests the path between switch 1 and switch 3, which deteriorates the quality of the video streamed to client 1. The performance monitor application registers a huge increase in the traffic rate at switch 1 once the additional traffic is applied. The data traffic flows from the other server takes the same default path, that is other server switch 1 switch 3 client 2 as displayed in the web app. Both the flows from video server to client 1 and other server to client 2 takes the same default path, switch 1 to switch 3 as displayed in the web app. Let's configure the APIs to enable path policy. In flow condition, we need to configure the flow information for which path policy should be applied. For this demo, we have configured the flow details between video server and client 1. The flow details configured in flow condition API are the name video stream, Ethernet type, source MAC address and destination MAC address of the flows. Second, using path policy, we can define the cost of different paths in the OpenFlow network. The path policy details configured are the path policy ID, default cost, and cost for each link in the switches in the network. For this demo, the policy ID is 1, Default cost is configured as 1000. The cost between switch 1 and switch 3 links is configured as 1 million. Application of the path cost in the topology is shown with an illustration here. Before the path policy is applied, the default cost of 1000 is applied to all the paths. Video traffic takes the shortest path, that is switch 1, switch 3. Once path policy is applied, the cost between switch 1 and switch 3 becomes 1 million. And the cost between switch 1 and switch 2 and switch 2 and switch 3 continues to be the default cost 1000. After the application of the path policy, the video traffic takes the low cost path, that is switch 1, switch 2, switch 3, where the total cost of the path is 2000. Finally, path map is configured to map the flow condition and the path policy. For this demo, we map the flow condition video stream with the path policy 1, which were created earlier. Once the configuration is successfully applied, the quality of the video streamed to client 1 has dramatically improved. Using the web app, we can verify the flow paths. The video traffic flows between video server and client 1 are switched to the low cost path, that is switch 1, switch 2, switch 3. The other data flows between other server and client 2 continue to take the earlier path, that is switch 1, switch 3. By this, we have demonstrated the flexible path control feature supported by VTN in OpenDaylight controller. Thank you for watching this demonstration. The software and tools used in this demo are VTN project source in OpenDaylight, OpenStack iSource version, OVSDB plugin in OpenDaylight, web application for VTN coordinator to display the configuration information and data. Hello everyone, this is Sarath working in VTN project in OpenDaylight. In this video, the flexible path control feature of VTN project in OpenDaylight will be demonstrated. VTN stands for Virtual Tenant Network. VTN is one of the network virtualization models implemented in OpenDaylight. VTN project has two major modules. The first one is VTN Manager. It implements the VTN functionality in the OpenDaylight controller. The second one is VTN Coordinator. It's a multi-controller orchestration application which is part of the orchestration layer in the SDN architecture. Two features of VTN are demonstrated in this video. The first one is the seamless integration between OpenStack and OpenDaylight controller. The second one is the flexible path control mechanism in OpenFlow networks provided to OpenStack data center environments via OpenDaylight SDN controller.